Welcome back, students. Today we discuss about the operational amplifier IC741, the op-amp and its pin configurations, ideal characteristics of the operational amplifier, voltage follower, and etc. What is operational amplifier? It is a electrical and electronic IC741. The operational amplifier consists of two amplifiers inside it. What is amplifier? The amplifier is a electrical and electronic circuit which increases the input signal to produce an output signal which is much larger than that of the input. What it means? If you apply a signal, it is the amplifier circuit. If you apply a input signal, it is the amplitude. This amplitude of the input signal is amplified by the amplifier. It is an electronic circuit which amplifies the amplitude of the input signal. Okay, this amplifier circuit mainly consists of a transistor. It is a NPN transistor. You know already the emitter is always be connected in forward bias. Base also always be connected in forward bias. Collector is always be connected in reverse bias. What is forward bias? A p-type material is fed with positive polarity, or an n-type material, n-type semiconductor material is fed with negative polarity. This type of biasing is known as forward biasing. You know well that emitter is forward bias. In this transistor circuit, this transistor amplifier circuit, the emitter is biased using the resistor Re. Here the negative voltage is given through the resistor, and base is forward biased. It is p-type material through the plus VCC voltage. This plus VCC voltage is divided by these two resistors, and the resultant voltage is passing across, that is a positive voltage. As it is a p-type material, it is forward bias. And the collector is biased, that is reversed bias. It is a n-type material. A positive supply is given through the load resistor RL. So this is the capacitor C1. It is otherwise called as blocking capacitor. It blocks the DC voltage from the source, and it does not allow the DC voltage to pass through this. It allows only the signal to pass through it. The signal pass through the C1, comes here, and the positive voltage, DC voltage, also comes here. Both are combined and enters into the base region, and then it is amplified by the transistor, and it is appear at the collector output. Now it gone under 180-degree phase reversal. So it is like this: input is, but output is 100-degree phase reversed. So the amplitude of the input signal is amplified here. So it is the simple explanation about the what is amplifier. So in operational amplifier, there is a differential amplifier. There are two differential amplifiers. It is a one amplifier. Here the NPN transistor is biased, emitter is biased by Re1, collector is biased by Rc2, and the base, it is input is given at the base. Here also another transistor Q2, its emitter also biased using minus VEE, and the emitter resistor Re2, collector is biased using the resistor RC2 and plus VCC. The input is given here, now it is grounded. The two amplifiers are coupled here. The RC1 and RC2 are connected and the common positive VCC is applied here. And the emitters RE1 and RE2 combinedly called as RE. And the potential given to this, the biasing voltage is minus VEE. So, the first signal, signal 1, the input 1, is given to the base of the first transistor Q1 through the resistor RB1. And the second input, second signal, second voltage V2 is given to the base of the second transistor Q2 through the resistor RB2. This is a one differential amplifier. In operational amplifier, the two differential amplifiers are cascaded. It is the one set, it is another set. Here, there are two inputs. This is the first non-inverting input. It is another input called as inverting input. This is known as inverting, this is known as non-inverting input. So the operational amplifier has two inputs. One is inverting, another one is non-inverting input. It has only one output, the sixth pin, it is the output. So the two differential amplifiers are cascaded in the operational amplifier. So the output of the first transistor Q1 is given as the input to the base of the transistor Q4. The same way, the output of the transistor Q2 is given to the input of the transistor Q3. Okay, so this output is fed to the input of the second differential amplifier. So it has only one single output, it is 6. The plus VCC is given at 7th pin, negative VCC is given, negative VCC is given at 4th pin. This is the internal diagram of operational amplifier. So the operational amplifier has two cascaded differential amplifier having two inputs, only one single output. The operational amplifier is a high voltage gain amplifier. They are standard building blocks of different analog circuits. Their most commonly used op-amp is IC741. The IC741 op-amp is a voltage amplifier. It inverts the input voltage at its output. So it reverses the phase. It is commonly found in number of electronic circuits. Let us see the pin configuration of IC741. It is a operational amplifier IC741. See here, it is the first pin. It is the first pin. It is second, third, fourth, and then here 5, 6, 7, and 8. The first pin of the operational amplifier IC741 is offset null pin. I will tell it later. Second one is inverting input terminal. Third one is non-inverting terminal. Here a negative VCC is given, negative voltage supply. And the fifth is also used for offset null voltage. Sixth one is the output voltage. Seventh pin is the positive voltage supply is given. Eighth pin has no connections. So this pin, this IC is appeared physically like this, and the internal diagram, the electronic circuit, the electronic symbol of the operational amplifier is like that. See here, it is a inverting input. It is non-inverting input. It is offset null balancing input pin. It is a negative voltage pin. It is offset null balancing pin. It is the sixth one is output pin. Seventh one is positive supply pin. Eighth pin has no connection. It is the circuit symbol of operational amplifier. Now we go to this diagram. See here, it is here a detailed configuration is shown here. This is the first pin is offset null setting, and the fourth one is negative VCC. Fifth one is off null setting voltage. Sixth one is output. Seventh one is a positive supply is given here. So number 2 is inverting input, and number 3 is non-inverting input. It is the electronic symbol of operational amplifier. Okay. Now how will you connect this? See, the operational amplifier, we should always use a dual power supply. What it is called as dual power supply. Plus 0 minus, plus 0 and minus. This supply is known as dual power supply. See here, this dual power supply, the positive is connected to 7th pin, the negative is connected to 4th pin, and the center one 0 is connected to 3rd pin. And then the input is given like this. A external battery is used. This positive is connected here, negative is connected here. It is a potentiometer. We can vary the voltage. We can take V1, V2 or V3 as a input voltages. It may be connected to inverting input or non-inverting input. Okay, V1, V2 and V3. The output is measured using this voltmeter. The positive is connected to 6th pin and the negative is connected to this ground minus. So this ground minus is connected to 3rd pin. It is the general connection for operation of IC 741. Now we go to the op-amp parameters, the characteristics of IC 741, the characteristics of the operational amplifier IC. Open loop gain, it has a infinite open loop gain. What is open loop gain? It is a gain produced by the operational amplifier. It amplifies the very weak input signal as it is had high input impedance and low output impedance. It amplifies the weak signals and gives very high gain, the range between 20,000 to 2 lakhs decibels. Now the next characteristics is input impedance. Input impedance nothing but input resistance. Already I told you the operational amplifier has high input impedance. So it is a infinite. The input impedance is the ratio of input voltage to output current, and it is assumed to be infinite. To prevent any current flowing from the source supply into the amplifier input circuitry, it used to avoid the damage, and it has very high input impedance. So it used to amplify very weak signals. Okay, what is output impedance? Output impedance is 0. It is nothing but the ratio of the output voltage and output current. The output impedance of the operational amplifier is nearly 0. But its real amplifiers, its output impedance is taken from 100 to 20 kilo ohm range, and it has another parameter called as bandwidth. It has infinite bandwidth. What is bandwidth? The operational amplifier is used to construct an amplifier. The graph is drawn between the frequency and the gain. In this characteristics graph, we get very larger bandwidth from lower cutoff frequency to higher cutoff frequency. It has an infinite frequency response and can amplify any frequency signal from DC to the highest AC frequencies. So its bandwidth is infinite. And the offset voltage. What is offset voltage? This operational amplifier generates the output voltage without giving any input voltage. But generally, an amplifier should not produce any output on giving if there is no any input signal. So it generates some output without giving any input signal. So this type of voltage is known as offset voltage. The amplifier's output will be zero for the ideal operational amplifier, but it generates some voltage. The voltage is nullified using the circuit. The circuit consists of a pot, a potentiometer, variable resistor. It is connected between the terminals 1, 4, 5, and on adjusting 1, 4, 5, on adjusting the value of the potentiometer, the internal impedances, that is, the offset voltage is produced due to the mismatching of the output impedance of the first differential transformer and the input impedance of the differential transformer. The both impedance are not matching. Due to this reason, this amplifier produces a offset null voltage. So this voltage is nullified using this potentiometer. It is connected between 1, 4 and 5. This voltage is called offset null voltage. Some real amplifier has some amount of offset voltage. Okay. Next characteristic is common mode rejection ratio. The common mode rejection ratio is nothing but the ratio of differential mode gain and common mode gain. Its ratio of the common mode gain to differential mode gain is very high. And the next parameter is power supply rejection ratio. It also defined as the changes in input offset voltage per unit changes in the DC supply voltage. So PSRR of the op-amp is also calculated in decibels. Next, virtual ground. What is virtual ground? We know what is ground. Any terminal which is physically connected to the ground is known as ground. But here, the voltage at a particular node is almost taken to ground voltage, but it is not physically connected to the ground. This ground is known as virtual ground. This ground is known as real ground. It is virtual one, it is a real ground. So, the virtual ground is available in operational amplifier circuits. The real ground is when the terminal is connected physically to the ground or earth. So it is equal to 0 volts. Virtual ground also taken as 0 volts. Now the operational amplifier working as a voltage follower. What is voltage follower? A voltage follower is nothing but a buffer circuit. The output follows, the output voltage follows the input voltage. The voltage follower circuit using op amp whose output voltage is straightway follows the input voltage. That is, the output voltage is equivalent to input voltage. It does not provide any amplification, so its gain is equal to 1. It is also called as buffer. What is the uses of the buffer? It is used to isolate the input from the output. The circuit is shown here. The signal is given to non-inverting input and the inverting input is shorted with the output. So the given signal, the input signal is given here. It is appear in the output. So 10 volt input is given here. A 10 volt output is appear at the output. So the output voltage is equivalent to the input voltage. This is the action of voltage follower. It is used to isolate the input from the output. Okay, now we have discussed what is operational amplifier, what is IC741, what are the pin configurations, pin configuration of IC741, and what is optional set voltage, what is the parameters and ideal characteristics of op amp, what is virtual ground, what is the difference between the virtual ground and real ground, and the voltage follower circuit. Okay, I have given some questions here. Write down the question and answer in your notebook and send its scanned copy to me in the second cycle of assignment. Okay.